All right, good morning and happy Wednesday. It's 4:49 in the AM, and I'm planning on doing the LeetCode contest from last Saturday. So I've been a bit behind lately. So anyhow, let's go to this. Get some leak coins. All right, so last Saturday's contest, November 4th. I'm going to do this guy virtually, 370. Okay, so here we go. It's time to shine. All right. 1, 2, 3, 4. I really like these ones that LeetCode has been doing like a first and second. So these are pretty cool. Anyhow, let's keep track of what time we have. It's 4:49 in the AM. Okay. And 03 minus 1 inclusive. Okay, inviting grid. I is stronger than J if it's 1. Otherwise, team J is stronger. Okay, it's either zeros or ones. I is stronger if it's 1, 0, or J is stronger if it's 0. If there is no team B that is stronger than team A, there's team B. Team 1 is stronger than team 0. Team is stronger than team 2. Okay. It's just kind of weird to look at, but so the game plan is just to go through and perform the simulation, perform consideration of all IJ teams, right? So basically traverse the two-dimensional array, right? Traverse 2D array, right? And we'll keep track of A and B, right? So there's our array, team A and team B, and then we'll return 0. Is 0 of A? Yeah, 0. Team A of a champion. Return the team that'll be champion. Oh, okay. Okay, so the teams are the rows then, right? Okay, yeah, so the teams are the rows. Teams are each ith row, and then the other team is each jth column, right? Let's say A teams and let's say B teams are each jth column. Okay, so we know not just these ones, but okay. We'll do a mapping basically, and then we'll turn it into one liner, right? So that's the game plan. So we'll map each ith row to how many teams are stronger than it, which would be the accumulated sum of each row, right? So let's do just our function. It'll be lambda row, it'll be the sum of the row. Actually, no, let's just do this. Just do this return. The maximum ith value. Hold on, let's do this. Let's just do a mapping to the sum. Like sum, it would be the sum of each row for row in A. All right, and then we want basically there's no team B. Oh, actually, maybe this is a directed graph then. Am I reading this wrong? So there's no team B stronger than team A, would be the champion. Team 1 is stronger than, or team 0 is stronger than team 1. Okay, so yeah, make sure we read this right. So each entry, right, IG entry is an edge. right? Team 1 is stronger than team 0. Team 0 is stronger than team 1. Okay, so this says this transitive property holds. So if each ij entry is an edge, then we'll say team 0 is stronger than team 1. Since the strongest, maybe we want to have the edge go backwards. 0 points to 1 and 2 points to 1, then 1 will be the champion. Okay, so the input basically doesn't contradict itself. Okay, you're never stronger than yourself. Okay, so they're opposite, right? If this is stronger than that, then that one is not stronger than this. Okay, yeah, so we'll create edges and then in reverse and then traverse those edges. Okay, so make each edge in reverse, then find lowest common ancestor. I mean, that's the point where it diverges, right? So the input should be set up so that there is one. Okay, so E will be our edges for, so I in range N, and it'll be the cardinality in array, and for J in range N as well. If I does not equal, actually, I don't need that check because it's gonna be 0. So if a sub I sub j, that means I is stronger than j. A dot append, we'll stick in here the reverse edge, right? Reverse edge is to find lowest common ancestor. I don't know why I'm second guessing myself, but I think this seems right, right? 0, 1, 2. Let me look at this real quick. Just make sure I understand this before I go further down this rabbit hole. All right, so here's our input grade. So each ith row is a team, 0 to n inclusive. All right, so team 0, team 1, and team 2, right? Team 0 is stronger than team 1. Team 1 is, or team 2, right? Team 1 is stronger than team 0 and team 2. Team 2 is not stronger than any other team. So this seems like a good place to start the traversal, right? Start here for reversed traversal, right? Or traversal of the reversed edges. Seems to make sense, right? And then it'll go team 2 points to team 1. And that's it, right? Team 0 is stronger than team 1. So 1 points to 0. 1 is not stronger than anyone. Okay, that sounds good, right? So this will be our source vertex. And then our answer will be the destination vertex. Okay, so all right, so instead of edges, we'll want to create an edge or an adjacency list. It should be fine. Okay. No, adjacency list, so I can look it up real quick, right? Yeah, an adjacency list to be a default dictionary. Just a list. Each of these should just have one in reverse. Adjacent to J. I. If we need the default dictionary list, right? Just make it a map. Adjacent to J equals I. Okay, then start with the node with none. Let's do this. Nice. Such that if the sum of the ith row is 0, now adjacent has next. Let's see. I would have a node is in adjacent. Node equals basically the parent, right? Let's call this guy parent. 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 Oops. Uh-oh. What am I hitting here? Parent. Okay. And then return node. Let's see what happens here. Okay, it is 503. 503. 0 and 1. Okay, that looks good for the inputs. Let's see what happens. I'll submit it. All right, cool. So that took about 14 minutes. The implementation in Python 3, which is accepted. Yay. Okay, so that's just kind of weird. Took a little bit to understand the problem statement itself. Okay, so yeah, there we go. That works. And drain. How can we shorten this up? And if we want to, I guess this one's used to traverse parents. That is find lowest common ancestor. I think that's a key thing. I'm wondering if and how we can make this a little bit more clear. So what do you want to call this guy? Parents. The parent is stronger than its child, right? Parents, parents are stronger than their child. Their child's parents are stronger than child's. Think of like a strong arm. Right? The lowest common ancestor is of the reversed graph is the strongest parent. Oops, excuse me. Okay, yeah, so the simplicity of this code assumes that the input is valid, right? So, and that's all there is to it. Seems like a decent solution. What's this dude slowing? Let's see. Oh, nice. Oh, yeah, that's way better than what I came up with. Yeah, I guess that makes sense. If this is that guy, yeah, that's a way better solution than what I came up with. This is awesome. Yeah, right. That's fun. Thanks for sharing. This dude's super cool, and unfortunately, he's been drowned out by a whole bunch of nonsense from other folks. Mainly this dude. Yeah, huge bummer to see the complexity, like his complex solutions being propagated to the top because complexity is not intelligent, not one bit. It's like the blind leading the blind. And it's extremely frustrating. Oh well, and what do I know, right? I mean, I'm not even a contestant, right? So at least I know I'm legit. I'm in here working my ass off day in, day out. Whatever. All right, let's move on. Focus on the positive, focus forward, focus on ourselves, right? Either change ourselves or we change the world, right? Okay. Yeah, I have a lot of room for improvement, so I'll focus on myself and quit rambling. It's 5:08 in the AM and we're on Q2. So we have 1 hour, 11 minutes left. And okay, it's 1 hour, 11 minutes. Try not to get frustrated, right? Definitely don't want to get emotional. That's not going to help anything. Okay, so there's in the same thing. Each team is a node and a directed. Okay, yeah. Yeah, this is how I thought of the question initially. Yeah, basically the reverse edges, right? So, okay, so this one, there's more than one possibility for the leaf node. Okay, so, 'cause, 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 ' Oh, they're giving the input actually as edges this time. Okay. Know how to derive the input. Yeah, so that's good to note and worth mentioning, right? Usually, whenever I miss problems or have difficulty with problems, like this one took me 14 minutes, it's because I have low quality of thought. That is, I'm making the problem more complex than it actually needs to be, right? So, following coach's advice and what I've observed is KISS, a simple card counting strategy that is keep it super simple, right? And that's what Vlad, the programming coach, does well is he keeps it super simple, and he's an awesome dude to learn from. All right, so return, oops, ith value or I in range, oops, this guy, if sum of the ith row, oops, is equal to the cardinality in parade minus one, right? You're stronger than all other n minus one teams. And again, simplicity is intelligent, not complexity, right? So this is what we're aiming for, something super simple, not this, right? So that's a good example of what not to do, and it's a good learning experience, right? So I am willing and able to improve. Let's see, a few solutions. Turn the team which is stronger than the other n minus one teams. Turn the right. Oops. Kotlin, JavaScript. Oops. Python 3, Rust, C++. Actually, I should give this dude credit too, because this is not my idea. We'll look at a couple of the other guys' solutions. Yeah, even that guy's solution is probably overly complex, like what I came up with. All right, holy cow, Hoban. Let's see, yada, 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 yada. Okay, let's see what we got here. Okay, so this one's good. Upvoted. This one's junk. This one's junk. This one's decent. This one's junk. This one. Yeah, that one's kind of cool, actually. It's a cool way of thinking of things. Actually, I like this one. Yeah, that one's cool. This is the same thing, but kind of more complex, I think. Chunk, chunk. Okay, this one's cool. Give this dude credit for my solutions. Note, I originally coded this complex solution. Let's see, and then give that dude credit. This one's kind of cool because my wife and I, we like to kind of joke around that she has a strong arm. So this is the strong arm, right? Parents are stronger than their children, right? So use the reverse edge of each children to find the lowest common ancestor, which is the strongest parent. All right, and this is our target. A little bullseye here. A little star here to highlight. We're using the reverse edges to traverse this graph. that is the strongest parent. Reverse edge to traverse parents. This is an arbitrary choice. Right, there could be multiple starting indices. Text. Team which is not stronger than any other team. The weakest team. The weakest team, which is not stronger than any other team. Right. This dude's solution, super cool. Okay, so it's good to spread that kindness and love for goodness. And it's a good reminder too to be compassionate and empathetic with others, right? Every soul is deprived of truth against its will. And I do believe we're all trying to do our best to help each other out as well as ourselves. Though I also believe in the Dunning-Kruger effect, that is, some task and settings preclude people from receiving self-correcting information that will reveal the suboptimal nature of the decisions. So although I think some folks do mean well that they're posting their solutions, they are overly complex, right? And they don't even realize that they're overly complex and that they're not intelligent. But again, what do I know, right? I have a lot to learn still myself. Here, right? So I can admit my ignorance here. Oh, right, in about 14 minutes. Okay, so yeah, one-liners are fun to write. It is pretty cool. So here we go. This guy. And then this guy write it next. Interesting. All right. Sharpen this up a little bit. Oops. Actually, yeah, so actually I just want to return the ith row, right? Return ith row. So I'm transponding to row. Yeah, let's just go by one by one. So C++ excels in procedural programming, right? We'll return before I get here. So if let's do this, just stick it in here. Doesn't matter. Okay, so if accumulate a sub I begin a sub I end is equal to n-1, return I. Oh. Oh. Yeah, I guess we can stick this thing as an int. Oh, really? Okay. Never it in. It's a size T. And it does make it a little bit easier to read, right? Okay, so this would be super sketchy to do if a dot size, if a could be empty, right? Because then this would be like a gigantic number. But in the context of LeetCode, this is sufficient, right? It's good enough. You can see how C++ is very verbose and procedural. And then we'll see the equivalents in Rust, JavaScript, and Kotlin in a functional way. And the reason why functional programming is so powerful, I think, is because it's super simple to read. You can see what we're doing. Like it explicitly states what we're doing, not how it's being done. Right? You got to kind of assume that how it's being done is the correct way in the underlying language itself, the APIs that we use, compared to C++ is backwards. C++, you write in a procedural way, you describe how you're doing something. And from that how, you can derive the what via reverse engineering. So it's a different programming paradigm, but it's super powerful, and I'll demonstrate like how it's powerful, right? But just basically, we're gonna go through each ith row. So we'll go a dot map or just filter each ith item of the input array A to be using Lodash sum of the ith row, where that sum equals the cardinality input array A minus 1. And after we've filtered it, let's see, so each room, oh, actually, actually, let's see, how do we want to do this then? Maybe I'll set it to -1 or the ith row itself. See, if I do this in Python 3, the sum, yeah, I filtered all I, where the sum is equal to that. For each ith row, but then I want to keep I. Map this guy. Something like that might work, right? Oh, sum is not a function. What dash sum? Really? Could have sworn Lodash had a sum function. The heck did LeetCode lose its ability to use Lodash? A sub I dot reduce a b a plus b. I think that's the accumulator and an hbth value. I is not defined. Oops. Ith index 0 and -1. What? Yeah, so I guess the downside of functional programming, it is like kind of more challenging to debug, right? So there's stuff going on behind the scenes here. So why is -1 being returned? What the heck is going on here? Where I does not equal -1. Oh, actually, I don't want to. Okay, so yeah, so I'm mapping each ith index of A, just each ith row. Row sum is equal to the cardinality of array A minus 1. What the heck is going on? I don't know. Let's do this. Just up this thing. Should be the one that's not -1. What the heck? It's not filtering it right. Oh, oops. Okay. I see. Just map this guy. It's each ith value itself, right? Okay, that looks good. Oops. Okay, so there's a site typo there. So, I mean, it's nice to be able to debug this pretty simply too, right? It's not that challenging. So, it could be worse. I think the upsides of functional programming most definitely outweigh the downsides. But this is strange. Why can't I use Lodash sum? Do I need to spread it? The heck? When I've used this thing before, Lodash sum is not a function. I could have sworn I've used this thing before. Let me see if I can find. Let's see. Actually, I might have Lodash sum here. Let's see. Yes, I've used this before. Can partition. Okay, so let's go to this. Let's go to this guy. And my logic is this, that if Lodash sum no longer works here, then it's no longer supported. What is it? Oops. Last submitted code. What's Lodash sum? Total. Okay. And if LeetCode lost the ability to use Lodash sum, that would totally suck. Lodash sum A. Yeah, it seems to be working. Why the heck can't I do Lodash here then? The heck? Lodash sum A sub I. Lodash sum is not a function. The heck? Let f equal sum, Lodash sum. For some reason, it works like this, though. What the heck is going on here? So, in this context, Lodash sum exists, but in this context, it doesn't. Interesting. All right, whatever. Okay, so anyhow, you can just use reduce here. That's fine. It's not, well, yeah, it's not very straightforward, right? This is a better solution, even those 2 lines. It's easier, I think, to not use reduce, right? Reduce is, I don't think, very straightforward. Okay, anyhow, let's move on. All right, here's our array. Change this into a lambda. Just to make it a little bit more concise. Type alias. This isn't exactly right, but Similar to Newtonian physics is good enough, right? Okay, so if we want to return a dot with index dot filter, that row sum is equal to the cardinality of array a minus 1. Map each ith row straight up to I. Return the first one. Uh-oh. What's it saying here? Oops. Looks good. Okay, that's cool. Yeah, whatever. This is good enough, right? Not exactly the same as the other ones, but it's pretty much just along the same lines, right? Accumulate the sum of each ith row and then filter it such that it equals the cardinal for a minus 1. That is the ith team that's greater than all other n minus 1 teams, right? Stronger than it. And then just take the ith one. Okay, that's assuming there's just one champion in there. So we can take the index 0 of that filter. Okay, so let's do this in Rust. And then this is taking a lot longer than I was hoping, but whatever. That's how I think slow and steady. Slow and steady is the way to go. So it's got me this far. So might as well keep going, right? Mm-hmm. All right. Slow and steady like a boring turtle. Why? Because everyone else is sleeping while I'm working my ass off. Slow and steady. Okay. Turn this up a little bit. Okay. Turn a dot enumerate into, oh, let's just do iter. Dot enumerate filter each ith row such that the row sum of vector network Rust vector there a sum function sum. Oh, okay, yeah, there is row dot iter and sum is what we need. It's 932. That's cool. Okay, this guy equals, oops, as a just do the length as I32 minus 1. Filter that and then map each ith row is just straight up I. And then return the 0th after we collect it to vector of integers. 32 I. It's I32. Since I is a U size. Okay, oh. Closure expected to take 2 to the argue. Oops. Yes, I want to true tuple argument. Thank you, Rust compiler. Thankfully, the Rust compiler does give pretty good output. It's verbose, but it's not as verbose as C++, and I think it is pretty decent actually. So the tool chain for Rust is pretty cool. All right, so there we have it. There's our solutions. Let's post that, right? Return the ith team, which is stronger than the other n-1 teams. All right. All right. Given the, let's see. Yeah. Let's do this. Let n be the cardinality of the input array A. That sounds good. Return the ith team, i.e. row. Oops, that is the row, right? Just stronger than the other n-1 teams. Okay, yeah, give that dude credit, right? That's pretty funny. Okay, so anyhow, I'm gonna get too lost in my social media and all this and that, right? Let's see. Totally wasting time getting distracted. Okay, so I only solved one so far. We got 40 minutes left. Oops. Okay. Well, that certainly is slow. Oh my goodness. Okay. Yeah, I need some more coffee here. Yeah, that sounds good. Okay. We're gonna have 0 hours and 40 minutes left now. Yeah, I'll grab some more coffee. I'll be right back. Okay, that coffee tasted horrible, so I'm not going to drink it. Well, I don't feel like doing another one either. Okay, so we got 40 minutes left. Let's get back to this. Yeah, okay, I knew this. This guy started that one. So I want the reverse edges. Same thing I was thinking of earlier, right? And if there's more than one, then return -1. Let's see. R will be our reversed edges, right? So EU for U, B, and E, each reversed edge, and then just start with the ones with no incoming. I guess, yeah, we can make just an adjacency list, right? Or just, we can do the same thing, just call it parent, right? So it's a DAG. So each of them would have a parent, right? There is no cycle, right? Right, okay. I think it's still safe. For U, V, and E, P sub V equals U. Right, so this looks good. And then let's start equals B for V and P if, or actually for V in range N, 0 through N-1 inclusive, if there is no parent in the reverse. So we start at 2 and 3, go back to these guys. B not in P. Let's make sure I got this right. So start would be 0, 3, and 2. 0, 3, and 2 should be printed for start, right? Come on, this thing is so slow. Oh, come on. 0, 0, and 1. Doesn't look right. 0 to 2, so do 2, 0. 2, 1. Oh, it wouldn't be any of the values. Okay. 0, 2, and 3. 2 should point to 0, though. P. 0 points to 1, and 2 points to 1. 0 points to 1. Wait a sec. 0 points to 1, 1 points to 2. 0 points to 1, 1 points to 2. So in reversed, 1 points to 0. Right, 1 points to 0. Right, and then 2 points to 1. 2 points to 1. This one points nowhere. Oh, okay, the ones that point nowhere. Ones that point nowhere. These guys point nowhere. 0 and 1 point nowhere. Wait, I think I had this. These are ones we want, right? Should be 0, and then it'd be -1 because it's 0 and 1, right? Yeah, okay, that's what we want, right? Okay, this is not start, this is like candidates. Return candidate sub 0 if length of the candidates is equal to 1, otherwise -1, like these multiple candidates for the parent in reverse. Okay, that makes sense, right? That looks good. Okay, cool. It's 5:46. That went on like a huge tangent though on that one. Okay, 33 minutes left. 0 hours and 33 minutes. So it took about 7 minutes, I'd say. That's not too bad. 7 minutes. And this is the way I was originally thinking of this problem is like a graphing problem. So it's kind of cool to see that as a follow-up. This one actually we can simplify in that we're looking for this guy. Usually it's something without anything pointing to it, right? So 1 is never the second value. 0 is also never the second value. Is equals this that of vertices where it's being pointed towards by you. Parents then be u for u in range in if u not in kids. Trying to see how we can make this a little bit more easy to see and read, right? So that's good. So here's our kids, which would be the vertices, which are the second of each pair UV in the list of edges. Parents would be HU for those UV edges. I think that's a little bit easier to read. We could think of them as start, end, begin, and begin. The first beginning. Right, this should work. Begin and end might be a little bit easier to understand, I think, than parent-child. Parent-child is kind of verbose, right? The nice thing about begin and end is that the character lengths line up, right? So kids and parents is like not the same length. This finish and start, these are not the same length either. What about this child and adult? Oh, there we go. Yeah, I kind of like adult child. A little bit more than begin end. Let's go with this. Okay. So let's see what other folks came up with too. Right. Cool. Degree zero, degree zero. Pretty simple. Pretty simple. Degree zero. Yeah, that works too. This is a different way of looking at the same thing. I don't think it's terribly too complex. Turn the parent is adult. Is an adult. Whom is not a child. If single parent exists. Right. Let adult be all nodes 0 through n-1 inclusive, whom not second. The pair of edges u v v Right, this sounds good. Let adult be all nodes 0 through n-1 inclusive who are not a child, i.e. v, the second of the pair of edges uv. Second of the pair uv in the input edges e. That sounds good, right? Little fun lookups. And maybe in degree is a little bit simpler. Yeah, whatever. It didn't have to be perfect. This is good enough too. Oops. Where are the edges? Set of edges. Child, and do Or h auto ith child from 0 to n-1 inclusive. Actually, we'll just go through these guys. Transform each edge. All right, so insert each pair.second into the set of children, and then we'll do this too, right? Set adult, adult, capture children by ref or child by reference. I should want to filter it out there, right? Okay, so let's just go through this then. Oops. Find oops, child.find I is equal to child.end insert and adult size is equal to 1, 0, that's -1. Okay. Oh, second. Oh, here's 1, 0. Oops. Go up to the vector then. Okay, that looks good. Good enough. Plus Python 3. Kotlin. JavaScript. Let's do this. Oops. That child equals a dot map uv into v as a set. Spread that thing. Adult equal Lodash range 0 through n-1 inclusive. Dot filter. Child does not have you. The adult's length is equal to 1. Return adult sub-0, otherwise -1. Okay. No. Number 1 is not iterable. Oh. Yeah, I don't need to spread it then, right? Iterable. Okay. Oops. Submit. Okay, that looks good. Could turn this into a one-liner just for fun too. All right, butcher this thing up a little bit. Just stick it here. And I think this adversely affects readability significantly. So This is not something I'll keep, but we could squish it up there if we wanted to. Okay, so Kotlin in the bar files by e dot map enter a UV. I don't know if this works or not. Let's see what happens. Can I destructure an int array? No. E dot map. It's one, which is a pair. This should work, right? Sure, it's taking a while. Okay, that works. Yep. Bolts 0 through n-1 inclusive dot map dot filter child does not contain it. If adult size is 1, then return adult sub 0. Otherwise, -1. Big money, no whammies. Come on. Looks good. That's cool. All right. Yeah, when that thing turns green, I get a little dopamine rush that keeps me coming back for more. You do this in Rust, and then we got 16 minutes left. The time goes by pretty quick, I feel like. And that's a good sign that I'm doing what I like, even though I'm not that great at it. I still have a lot of room for improvement, right? Whatever. I'm in it for the long haul. Sounds cool. All right, so let child be all the edges to iter filter edge such that, or no, filter map each edge into second of each pair. To a hash set. Choose. Okay, so on a hash set, our set, and then let adult equals 0 through n-1 non or yeah, 0 through n-1 inclusive into enter filter vertex such as the vertex is not in the child. Text. Like this into vector of I32s. 0 through n. If adult length is equal to 1, then return adult 0, otherwise return -1. Okay, something like that. Looks good. All right, it's cool. Oops. All right, here we go. Return the parent if a single parent exists. Let adult be all nodes 0, 3, and minus 1 inclusive, whom are not a child. That is the second of the pair UV V for the input edges E. I mean, it seems pretty intuitive, right? I like that way that adult and child line up too. To me, it looks nice. Okay, so there we go. There's Q1 and Q2, and I've wasted a lot of time. We'll start Q3 and see what happens here. We have 12 minutes left, and it's Q3 time. Oops. I don't think I wasted time in hindsight, actually. I have a good time, even if I miss them and go off on tangential, overly complex solutions, right? It's a good learning experience. Mm. Maximize the score. 20,000 nodes. Seems like we can do a top down and then post post traversal, right? Bottom up, add the things, path, or actually go top downwards, keeping track of the sum of the root to the sum of values on the path from root to leaf is different than 0. Okay, the root is non-zero. Or use the maximum score we can obtain. We can choose nodes 0, 2, 3, and 4. 0, 2, 0, 2, 3, and 4. So we skip 1, 5, and 6. Okay, so we want to cherry pick nodes and we set them to 0 as we cherry pick them. So if we zero out this guy, then these have to remain non-zero. Okay, so yeah, this does look like dynamic programming offhand, right? So top-down recursion, I think we can use plan top-down, oops, recursive solution, and then plus memo to avoid tealing. So I do see how we can make a 0-1 knapsack solution. But I think that our TLE Maybe either include or exclude each edge. If you include it, then you take it in your total. I suppose that's a good way to start. Zero knapsack. As we include or exclude each ith item. Edges. So I want to create that into an adjacency list. So as we traverse, there's our array of values for U, V, and E. Let's see. Oops. U, V, E. An adjacency list. ADJ. Default dictionary. List. Pin V. So we should be able to traverse this thing using the adjacency list, and for stuff go. You always start off at 0. No, not necessarily, right? Okay, start will equal. It's just one connected component, right? An undirected tree. Yeah, so the tree implies one single connected component, right? Start. So yeah, I'm not sure if I want to go down this path or not. We got 6 minutes left, so I'm gonna go slow and I'm not gonna rush this. I'm gonna save this guy for solving next. So this is usually where about it's like 1/3. I mean, I don't know, top 25 to 30% or so. It sure is awesome to see that other folks solve these ones. And well, this one took me 7 minutes. This one took 14 or so. So a lot of this additional cost was solving it in multiple languages, right? Which is cool. Where's this dude from? Mongolia? Oh, that's cool. Oh, it's awesome to see this guy jamming. Super cool. It'd be nice if LeetCode had a way to give people tips. I tip this dude. you know? Yeah. Yeah. Okay. So I got like 5 minutes left. Let me think about how to do this concisely. And I'm thinking, yeah, top down traversal seems like it makes sense, right? You either take it or you don't. And I suppose actually there are no negative values, right? Holy values is huge. And since there's no negative values, I agree algorithm is what we want. Regionally consumed. If we take this, then it means we can't take anything lower than it. So I wonder, bottom up greedy consumption, does that work? We take 0, 0, 2, and 3, 0, 2, 3, and 4. Well, I guess we can take the whole level. Right. Ah, I see. We either take this guy or we take its two children. Take this guy or its child. I see. Okay. Yeah, that makes sense. Right, it doesn't make sense to, if we take this one, then we have to leave both of these. Right, so take that. Pretty sure, yeah, I think that's the trick, right? Was my parent chosen? If my parent was chosen to leave, I guess we can take everything. I take this chunk. And then at this point, does it make sense to replace this sum with this sum and propagate it backwards? I don't know, this is a little bit tricky, but I'm pretty sure I got the gist of it. I don't think I'll solve it in a couple minutes though. Which is cool with me, right? Fast is slow and slow is fast with people. It's a paradox. So I'll get there eventually. As long as I go slow enough, I think. Eventually go fast. This guy's worth 20. This guy's worth 10. Yeah, I think I need to just write this down on a piece of paper and kind of work through it. I'm pretty sure that's the slow way that'll get me going faster. I'm trying to imagine this in my head. And it's just too much. I'm like, look at these values 20, 10, 9, 7, 4, 3, and 5. And let's write this down. Pretty sure this is what I've been missing for quite some time for actually improving, is just going like super slow, writing down the input, taking some more time with the Q4s, which I think are kind of scary. So demystifying and de-scaring those. Okay, so this guy's worth 20. This guy's worth 10. This guy's worth 9. This guy's worth 7, 4, 3, and 5. So it's either 3 and 5 or 9. So 9 is bigger than 3 and 5. Or 29, right? 29 is bigger than 3 and 5. 29 that way. 11 is bigger than 10. The other side. So I'll take the 11 and drop the 10. Okay, so the game plan will be this, right? Not this guy, that'll TLE. Recursion plus post order traversal and greedy consumption. That is, if the children sum exceeds the parent node value, then 0 out to the parent. I think that works. And we'll see. Oh, the contest ended. Dang it. Oh, well, I wanted to take a screenshot. Dang it. Oh, well. Well, that sucks. Okay, well, time's over. And that's cool to see these in different languages here. It's pretty. Okay, let's go back here. Fortunately, I didn't take a screenshot in time. But it's been a while since I've actually attended a real contest. Right, it's kind of bummed to get 2-1 a bunch of times. I was getting 3 for a while there. Okay, virtual. This is the guy I just did, so I'll take a screenshot of this guy. Unfortunately, it doesn't have the breakdown of my solutions. Let's do this. Stick it here in the recordings. Okay, well, I'm glad that I attended, and hopefully something that I shared was helpful for others that were watching too. And it's might not made the most benefit for others, but it's definitely beneficial for me to put the pressure on myself to know that I'm going to post these things, win, lose, or draw. I might make a complete idiot out of myself, which I often do. But whatever, what do I have to be scared of if, I make a fool out of myself so many times? Due to hedonic adaptation, I guess I care less. Anyhow, I'll catch y'all later.